Hi, I'm Cassie, and I'm going to walk you through question 13 of the AAMC's physics question pack. So what is this question about? This is all about the Doppler effect. Now, the number one mistake that I see most students make when they're studying the Doppler effect is that they focus on this equation that I've shown on the board here. And this is, an equation that all the Kaplan books and most of the MCAT resources are going to tell you need to understand this equation, you need to be able to plug into this equation. And from my experience, actually taking the MCAT and doing the AAMC's practice questions, they don't actually care about you being able to memorize this equation or plug into it. What they care about is you having a conceptual understanding of how the Doppler effect works, as is the case for most concepts that are tested on the MCAT. It's not just about memorization, it's about actually understanding what's going on. So what is the Doppler effect? Well, the Doppler effect is just the idea that sometimes we perceive the frequency or the wavelength of a wave as being different than it actually is. And why is that? Well, that's because there's relative motion between us, the person who's observing the frequency or the wavelength of the wave, and the source, the thing that actually is emitting the wavelength. So the classic example of this is an ambulance, right? So imagine you're sitting in traffic and an ambulance is coming closer to you. The closer the ambulance gets to you, the higher pitched you hear that siren of the ambulance, right? And that's because of the Doppler effect. So when two objects have relative motion between them, like you moving in a car and an ambulance moving towards you, and those two objects are getting closer together, then you're going to perceive the frequency as being higher than it actually is. Okay, so remember that ambulance gets higher pitched, right? And of course, wavelength always does the opposite of frequency because the two are inverses. And then if that ambulance is moving away from you and you're moving away from that ambulance in traffic, then there's relative motion. You're getting the two objects are getting farther apart from each other. Then you're going to perceive that that frequency as being lower than the actual frequency being emitted by the siren of the ambulance. So how does this Doppler effect thing apply in this question? Well, this question is really testing your understanding of how you can calculate relative motion. So let's break down what's going on in the question here. So we've got a stationary receiver, and it detects a change in frequency from a jet moving away from it at 300 meters per second. So what's going on there? Well, our receiver, in this case, is like the observer. It's the thing observing the wave. That if, again, there's relative motion between it and the wave, that receiver is going to detect a change in the frequency of the wave between its actual frequency, right? And then we have the jet moving away. So we're going to say jet away, and that is going to be the source of the signal, okay? So that's our source. So what's our relative motion between a jet moving away at 300 meters per second from a stationary receiver? Well, I'm going to basically draw that as here's our stationary receiver. I'm going to call this our R, and here's our jet moving away. We're going to call this J at 300 meters per second. Okay, so essentially our R is 0 meters per second, right? So what's the relative motion between 300 and 0? 300 minus 0 is just going to be 300 meters per second. So our relative motion here is 300 meters per second. So this is what we're looking to match in our answer choices, right? We're looking to find the answer choice that also has relative motion equal to 300 meters per second between the thing that's emitting the sound, right? In this case, the plane that's flying, and the receiver, the thing that's measuring the sound, the thing that's observing the sound. So in answer choice A, how much relative motion do we have? Well, the receiver is moving away at 900 meters per second. So basically, I'm going to draw that like this. This is my, I like to draw my 0 point to keep it kind of straight in my head. But so my receiver here is moving away at 900 meters per second. And my jet is moving away at 600 meters per second. So these are going in opposite directions, right? So one's in 900 meters per second, we're going to say to the left arbitrarily, and one's in 600 meters per second to the right. So what's our total relative motion? Well, since they're in opposite directions, you're going to add them, right? So it would be 900 meters per second plus 600 meters per second, which would give me a total relative motion of about 1,500 meters per second difference between our source and our receiver. Okay, so that doesn't add up to our 300 meters per second, right? So we know it's not going to be answer choice A. Okay, what about answer choice B? Well, in this case, our receiver is moving, again, I'm going to make my starting point my 0 point, just to visually represent this. My receiver is only moving to, we'll say arbitrarily, to the left at away at 300 meters per second, right? So again, this is my R, my receiver. So it's less than the 900 meters per second in answer choice A, but it's still moving in the opposite direction as my jet, which is moving to the right at 600 meters per second. So again, what's my total relative motion between these two objects? It's just going to be 600 plus 300, which is going to give me a total relative motion of 900 meters per second between these two objects. Is that equal to the 300 meters per second of relative motion we're looking for? No, so let's cross it out and let's move on. Answer choice C, the receiver is stationary. So in other words, if I draw my 0 point here and my receiver is right here, and my jet is moving away at 600 meters per second, then essentially you've got the difference between 0 and 600, right? So basically 600 minus 0. And so my total relative motion is just going to be 600 meters per second. That's too much, right? We're only looking for 300 meters per second of relative motion. So all right, we know it's not answer choice C. So we know by process of elimination it's got to be D, but let's double check our work to make sure. So answer choice D says the receiver is moving at 300 meters per second in the same direction. So again, I'm going to draw my 0 point here, and I'm going to say this is my receiver, R, moving at 300 meters per second to the right, arbitrarily. And then let's grab a different color here and say that this is my jet moving at 600 meters per second. Again, in the same direction as the receiver in this case, unlike all the other cases. So how much is our relative motion between these two? Well, it would just be 600 minus 300, which would give me 300 meters per second, which is exactly what we're looking for, right? So the answer choice here is going to be D. So just a quick recap, right? If you get another question like this on the day you're actually taking the MCAT, what are you going to do? You're not going to worry about the formula you might have read in a Kaplan book or anything like that. You're just going to think about the concept of relative motion, and you're going to calculate how much relative motion there is between the two objects, right? And of course, direction matters. So if objects are moving away from each other, then they're getting farther away. You're going to add up those relative speeds to get your total relative motion. If objects are moving in the same direction, then to figure out their relative motion, you're going to subtract the speeds to figure that out. So that's it for this question. If this was helpful for you, please give it a like and subscribe to my channel for more content like this.